You hear the stories, tanks, fighters, submarines, but nobody talks about the gun that made concrete fortresses disappear. The weapon so big it needed its own railroad? The shell so heavy it could punch through 30 meters of earth and 10 meters of reinforced concrete in a single shot. In March 1942, German forces rolled something into the Crimean Peninsula that weighed 1,350 tons. It stood 38 feet tall. It stretched 155 feet long. And when it fired, the blast could be felt kilometers away. This is Schwerer Gustav, the largest gun ever fired in combat. The question isn't just how they built it. The question is why a weapon this monstrous only fired 47 times before vanishing into history. Gustav Krupp von Bohlen und Halbach, head of the family empire, waits to show him around the factory floor. Hitler has been chancellor for 3 years. He's remilitarizing Germany in violation of the Treaty of Versailles. The Rhineland was reoccupied just weeks earlier. Now he needs weapons. The Krupp family has supplied German arms for generations. Big Bertha came from these factories in World War I. Now Hitler wants something bigger. He asks one question: what weapon can smash through the Maginot Line? Gustav has an answer ready. His engineers ran calculations a year earlier in 1935. The Wehrmacht requested ballistics reports for guns firing 27.6, 31.5, 33.5, and 39.4-inch shells. The goal: fire from outside enemy artillery range and penetrate 23 feet of reinforced concrete or 3 feet of steel armor. Krupp's engineers dutifully calculated everything, but they took no further action. Now, with Hitler standing in the factory, Gustav recalls those calculations. He explains the numbers. They studied 70-centimeter guns, 80-centimeter guns, 85-centimeter guns, even 100-centimeter guns. The French built their border fortresses with 7 meters of reinforced concrete. Some positions had 1 full meter of steel armor plate. Standard artillery couldn't touch them. Gustav tells Hitler that Krupp can build an 80-centimeter railway gun. It will fire a 7-ton shell. It will punch through any fortification from beyond French artillery range. Hitler's eyes light up. He wants this weapon. He demands completion by March 1940. Gustav agrees. Hitler approves immediately. Within months, the German Army High Command, the Oberkommando des Heer, officially commissions Krupp in early 1937 under the designation 80-centimeter Kanon E. The weapon will weigh over 1,000 tons. You can't move it on roads. You can't mount it on a vehicle. The only option is twin railway tracks. The gun will elevate to aim. To traverse left or right, you move the entire weapon along curved track sections. Miller starts designing. Gustav Krupp names the project after himself. Schwerer Gustav, Heavy Gustav. The first gun begins production in late 1937 at the Krupp factory in Rügenwalde, now Darłowo in Poland. The barrel alone weighs 400 tons. It consists of 2 halves. The rear half gets covered by a steel jacket. The complete barrel measures 32.48 meters, 106 feet 7 inches. The rifling cuts 0.39 inches deep, 10 millimeters. Every detail is precision work. The breech block weighs dozens of tons. 4 hydraulic recoil absorbers attached to the cradle. Trunnions hold the gun cradle in 2 massive carriers. The system can elevate from 0 to 65 degrees. The gun sits on a specially designed chassis supported by 8 bogies on 2 parallel railway tracks. Each bogie has 5 axles. Total count, 40 axles, 80 wheels. The assembled gun weighs 1,350 metric tons, 1,490 short tons. Each component must be machined to exact specifications. The tolerances are measured in millimeters across structures weighing hundreds of tons. Traditional manufacturing methods don't work at this scale. Krupp develops new techniques, new tools, new quality control procedures. The hydraulic recoil system requires custom fabricated cylinders. The pistons are machined from solid steel blocks weighing tons. The seals must withstand enormous pressures without leaking. Every part is tested, retested, refined. The assembly process itself is an engineering challenge. How do you join components weighing hundreds of tons with millimeter precision? Krupp builds special jigs, custom lifting equipment, rail-mounted cranes that can handle the loads. The first round fires from a makeshift carriage on September 10th, 1941, at Hillersleben. Just a test. Engineers monitor every parameter: barrel stress, recoil distance, carriage stability. The test succeeds. November 1941. The barrel travels to Rügenwald for 8 more firing tests. They use the 7,100 kilogram armor-piercing shell. Range, 37,210 meters, 23.12 miles. Each test firing is documented. Shell velocity, trajectory, impact accuracy. The gun works. Now they need a war to use it. Siege documentation at the Bundesarchiv Militärarchiv in Freiburg dating from Operation Sturfang in June 1942. These aren't the usual Wikipedia sources. These are primary military documents, trial transcripts, and engineering specifications straight from the factories and battlefields. Now back to the information. Schwerer Gustav begins its journey to Crimea. The transport train stretches 25 cars long. Total length, 1.5 kilometers. Nearly a mile of rolling stock just to move one gun. The train includes ammunition cars carrying dozens of 7-ton shells, accessory cars with tools and spare parts, gondolas hauling the bogies and wheel assemblies, special flat cars reinforced to carry barrel sections and the massive cradle. 2 cranes, each capable of lifting hundreds of tons, roll on their own cars. The railway infrastructure must support this convoy. Bridges are inspected and reinforced, curves are checked for clearance, grades are analyzed for maximum load. The train can only move on certain routes. The Wehrmacht's Transportation Command coordinates the movement with military precision. Schedules are planned around other traffic, supply trains, troop trains, hospital trains. Gustav's convoy has priority but can't disrupt the entire rail network. The route runs through southern Poland into Ukraine, following captured cities, using the new German railway built from Ukraine to the Crimean Isthmus. The journey takes weeks. At each stop, guards deploy. Luftwaffe fighters patrol overhead. Flak batteries set up at vulnerable points. Allied reconnaissance aircraft search for high-value targets. A gun this size can't be hidden. Gustav reaches the Perekop Isthmus in early March 1942. It waits there until early April. The target, Sevastopol, the Soviet Black Sea naval fortress, one of the strongest defensive positions in existence. At the end of the spur, they construct 4 semicircular tracks. Gustav needs these to traverse and aim at different targets. Outer tracks support the massive cranes required for assembly. The work takes weeks. 4,000 men labor to get the gun into firing position. They dig embankments. They reinforce track beds. They assemble components piece by piece. The barrel arrives in 2 sections. The cradle comes separately. The bogies roll in on flat cars. 2 German flak battalions deploy around the site. Allied aircraft could spot this monster from miles away. It needs protection. 500 men will operate the gun when it fires. 5 weeks of preparation. By June 5th, 1942, Gustav is ready. The Luftwaffe's 8th Air Corps flies 23,751 sorties in June alone. They drop 20,528 tons of bombs. The intensity exceeds Warsaw. It exceeds Rotterdam. It exceeds London. German artillery pounds the defenses. 785 German guns and 112 Romanian guns hammer Soviet positions. 3 Karl Garret 600mm self-propelled mortars join the bombardment. Thor, Odin, one other. Each delivers 1.4-ton shells, but Gustav delivers 7 tons. Between June 2nd and June 6th, German artillery fires 42,595 rounds, 2,449 tons of munitions. And then Gustav speaks. Each projectile weighs 4,800 kilograms for high explosive rounds, or 7,100 kilograms for armor-piercing rounds. The high explosive shell contains 650 kilograms of explosive filler. The armor-piercing shell has a hardened steel core designed to punch through fortifications before detonating inside. The propellant charge alone weighs over 1 ton. Loading takes 30 to 45 minutes per round. The shell arrives on a special rail car. A crane lifts it. Workers guide it into the breach. The propellant follows. The breach closes. 500 men coordinate every movement. One mistake kills everyone nearby. The muzzle velocity reaches 820 meters per second. 2,690 feet per second. When a Gustav shell hits, it creates a crater 10 meters wide, 10 meters deep, 30 feet across, 30 feet down. The sound of impact carries for kilometers. Witnesses report feeling the shockwave in their chests from over a mile away. Buildings shake, windows shatter. The psychological effect is devastating. Manned by the 365th Battery, 61st Flak Regiment, and elements of the 1st Battalion, 1165th Infantry Regiment from the 345th Rifle Division, 4 76.2mm anti-aircraft guns defend the fort. 3 concrete machine gun casemates provide additional firepower. Gustav fires 6 shells. The fort doesn't neutralize completely. The guns keep firing. But the structure cracks. The defenders hold until June 13th, when German infantry from the 16th Infantry Regiment under Oberst von Koltitz assault the position at 0300 hours. By then, 3 of the 4 anti-aircraft guns are destroyed. The fort falls. The Soviet defenders endure apocalyptic bombardment. Fort Molotov's exact casualty numbers aren't recorded in surviving documents. What's recorded is that German infantry later finds defensive positions obliterated, gun emplacements crushed under tons of displaced earth and reinforced concrete. The magazine sits 30 meters under the sea, 98 feet below water level, protected by at least 10 meters of concrete, 33 feet of reinforced protection. This is the shot that becomes legend. Gustav fires 9 shells. The first 8 search for the range. The geometry is brutal. The shell has to penetrate water, then seabed sediment, then layered concrete, then detonate inside a hardened chamber. The angle of approach matters. Gustav fires in a low-angle trajectory, not the 90-degree vertical plunge that propaganda later claims. The 9th shell finds the mark. The magazine erupts. The explosion is massive. One of the boats in Severnaya Bay sinks from the blast. Soviet supply lines to the port fortifications suffer immediate disruption. Historian Robert Forsyth, writing in his 2012 Osprey campaign volume on Sevastopol and his later work, Where the Iron Crosses Grow, points out that primary source documentation is thin. He searched 11th Army records and Luftwaffe reconnaissance imagery. The evidence shows Gustav scored hits in the general area, but definitive proof of penetrating the deep magazine is contested. The ballistic angle doesn't support a direct vertical strike, but the German operational reports from June 1942 list the target as engaged, and the magazine is destroyed. 9 shells fired, magazine ruined. 1 boat sunk. That's what the combat logs say. Every shell that lands ahead of German troops removes Soviet defensive positions. Machine gun nests, mortar pits, communication trenches. Gustav doesn't just destroy structures, it destroys morale. Defenders who survive 1 7-ton shell hitting nearby report psychological trauma. The sound, the concussion, the earth shaking like an earthquake. The fort's location protects one of Sevastopol's key approach routes. When Gustav silences it, German assault formations can advance with reduced casualties. Maxim Gorky. 2 sustains damage but remains partially operational. The coastal batteries represented some of the most powerful Soviet artillery in the entire defensive perimeter. Silencing them opens the seaward approaches. Gustav alone fired 47 rounds. Some sources say 48. The original barrel wore out. It already had 250 rounds of test firing before combat. Now it's done. The Germans fit the spare barrel. The worn barrel ships back to Krupp's factory in Essen for relining. Cost per shell, not publicly documented in surviving records, but each 7-ton armor-piercing shell required specialized metallurgy, precision machining, and custom propellant charges. The gun itself cost 7 million Reichsmark. In today's currency, adjusted for inflation and purchasing power, approximately 24 million US dollars. Near the railway station of Tatesy, assembly completes, the gun is fully operational. Then, the attack is cancelled. Gustav spends the winter of 1942 to 1943 near Leningrad without firing a single round. The most powerful artillery piece ever built sits idle, waiting, guarded, unused. Krupp charges the German army 7 million Reichsmark for this one. The first gun was free. Krupp gave it to the Wehrmacht as a demonstration of loyalty and capability. Dora deploys to Stalingrad. The gun arrives at its emplacement 15 kilometers west of the city toward the end of August 1942. It's ready to fire on September 13th, but the Soviet autumn offensive begins. Encirclement threatens. The Germans withdraw Dora before it fires. Some sources claim Dora fired during the siege. Others say it never fired a single combat round. The records are contradictory. What's certain is that Dora didn't impact the battle outcome. Stalingrad falls to the Soviets in February 1943. 20.5 inches, longer range, different shell. The design promised a range of 190 kilometers, 118 miles. Construction begins, but Allied bombing raids target Krupp facilities. In 1944, the incomplete Schwerer Gustav is irreparably damaged. Production stops. Parts of the barrel are found after the war in the Krupp factories in Essen. It never fires. Krupp also proposes a self-propelled version. December 1942. The Landkreuz P-1500 Monster, a tracked vehicle mounting the 80-centimeter gun. The design calls for a platform weighing approximately 1,500 tons. 35 meters long, 14 meters wide, powered by 4 Daimler-Benz diesel engines and 4 Maybach gasoline engines combined. Top speed, 15 to 20 kilometers per hour on roads. Primary armament, the 800mm Schwerer Gustav or Dora. Secondary armament, 2 150mm SFH 18L30 howitzers and sponsons. Anti-aircraft defense, multiple 15mm MG-151 machine guns. The proposal addresses Gustav's main vulnerability, dependence on railway infrastructure. A tracked version could traverse terrain. It could support direct assault operations, but the engineering challenges are immense. The weight would destroy most bridges. The ground pressure would bog it down in anything softer than concrete. The fuel consumption would be astronomical. The project never advances beyond paper studies. Minister of Armaments Albert Speer reviews the proposal and rejects it. Germany needs tanks, fighters, trucks, not 1,000-ton mobile fortresses. Why build Gustav in the first place? The answer goes back to 1934. The Maginot Line represented a strategic problem. France fortified its entire German border. The forts could withstand conventional artillery. German military planners needed a weapon to crack them. The specifications were clear. Penetrate 7 meters of reinforced concrete, or 1 meter of steel armor plate, from beyond French artillery range. Only a super heavy gun could do it. Krupp had the engineering expertise. The company built Big Bertha in World War I. That gun, the 42-centimeter Gamma mortar, destroyed Belgian forts at Liège in 1914. Big Bertha weighed 47 tons. Gustav weighs 1,350 tons, 28 times heavier. But the principle is the same. overwhelming firepower against static defenses. Blitzkrieg tactics bypassed fortifications. Mobile armor and mechanized infantry moved too fast for static defenses to matter. By the time Gustav was ready, the Maginot Line was irrelevant. The gun became a solution searching for a problem. Sevastopol provided that problem. The fortress couldn't be bypassed. It controlled the Crimean Peninsula. It provided a base for Soviet air attacks on Romanian oil fields. Hitler called it an unsinkable aircraft carrier. The Germans had to take it. Gustav helped. But was it worth the cost? Thousands of artillery pieces. Tens of thousands of rifles. The steel used in Gustav's construction could build multiple destroyers, or dozens of locomotives, or hundreds of trucks. The manpower assembling Gustav could form entire infantry battalions. The flak battalions protecting it could defend factories or supply depots. But the siege also involved 785 other German artillery pieces, firing 42,595 rounds in just 5 days. 23,000 Luftwaffe sorties dropping 20,000 tons of bombs. Conventional weapons did most of the work. Gustav was a hammer in a toolbox full of hammers, just bigger, slower, harder to use. The gun sat near Leningrad through winter. Then it returned to Germany. The Wehrmacht retreated on all fronts by 1944. The strategic situation collapsed. Gustav became a liability. Moving it required intact railways. Germany didn't control intact railways anymore. Allied aircraft bombed tracks daily. Bridges fell. Tunnels collapsed. Gustav couldn't move, couldn't hide, couldn't defend itself beyond its flak battalions. April 14th, 1945. One day before U.S. troops arrive. German forces destroy Schwerer Gustav to prevent capture. The location: a forest 15 kilometers north of Auerbach, 50 kilometers southwest of Chemnitz. They use explosives. The barrel shatters. The cradle buckles. The bogies are blown apart. American soldiers find the ruins on April 22nd. Photographer. The wreckage lies scattered across the forest clearing. A U.S. soldier stands next to the barrel for scale. The barrel diameter dwarfs him. The shattered steel is twisted, useless. In summer 1945, Soviet specialists study what's left. They measure. They photograph. They take notes. Autumn 1945. The Soviets transfer the debris to Mersburg. That's where they gather German military material. Then Gustav vanishes from the historical record. Scrapped. Melted down. Recycled. The largest gun ever built reduced to raw steel stock. No complete guns. No barrels. No cradles. A few inert projectiles exist in museums. London's Imperial War Museum displays one shell. It's massive. Visitors stand next to it. The scale is shocking. The shell alone weighs more than most artillery pieces, but the gun itself is gone. Military records in German and Soviet archives, oral histories from soldiers who saw it fire, Sevastopol residents who survived the siege. The physical evidence is scattered. A shell casing here, a fragment of rifled barrel there, but nothing you can point to and say, that's Schwerer Gustav intact. The barrel had to be machined to tolerances measured in millimeters across 32 meters of length. The recoil system had to absorb the force of firing a 7-ton projectile. The railway bogies had to distribute 1,350 tons across 80 wheels without derailing. Krupp's engineers solved problems that had never been solved before. They created drawings. They ran calculations. They tested materials. They built prototypes. They failed. They refined. They succeeded. Gustav worked. It fired. It hit targets. It destroyed fortifications. 47 rounds at one target. Then nothing. The Wehrmacht needed weapons that could be mass-produced, weapons that could be deployed quickly, weapons that could adapt to changing battlefield conditions. Gustav was none of those things. No gun could match that. The V2 was mobile, difficult to intercept, psychologically devastating. The V2 program also consumed enormous resources with questionable strategic return, but at least it represented new technology, new capabilities. Gustav was old technology scaled up. Bigger gun, bigger shell, bigger problems. Only 2 prototypes built. The Maus was too heavy for bridges, too slow for mobile warfare, too expensive to produce in numbers. Like Gustav, it solved problems that didn't exist anymore. But at least the Maus could move on its own tracks. Gustav needed railways, special railways, built by thousands of men over weeks. Simplified designs, reliable logistics. Instead, they built wonder weapons. Wunderwaffen, impressive, deadly, impractical. Gustav embodies that contradiction. A technical achievement that contributed almost nothing to winning the war. One historian described it as a white elephant, expensive, impressive, useless. Fort Molotov, coastal batteries, the ammunition magazine under Severnaya Bay, each shot removed Soviet defensive capability. Each successful hit saved German infantry lives. When you're the soldier assaulting Fort Stalin, and Gustav has already pulverized the bunkers, that matters. When you're the commander planning an assault, and Gustav can destroy an underground magazine that conventional artillery can't touch, that has value. Limited value. Specific value, but value nonetheless. By 1942, when Gustav finally fired, The strategic situation had changed completely. Germany was fighting the Soviet Union, fighting Britain, fighting North Africa. Resources were stretched. The gun designed for the Maginot Line had to find a new mission. Sevastopol provided that mission. But afterward, no more static fortresses needed destroying. The war moved too fast. Some argue that Germany should have focused on railway guns generally. Not super heavy guns like Gustav, but medium railway guns. Movable, deployable in weeks instead of months, capable of firing hundreds of rounds instead of dozens. The 28cm K5 railway gun, for example. Caliber, 280 millimeters. Weight, 218 tons. Range, 62 kilometers. The Americans called one captured K5 Anzio Annie. It shelled Anzio beachhead in Italy. That gun was practical. Multiple units deployed. High rate of fire, easy to relocate. Gustav was singular, unique, irreplaceable. They provided the breakthrough needed for the Schlieffen Plan's opening phase. Gustav destroyed Soviet forts in days. One gun deployed. It fired 47 rounds total. It moved once to Leningrad, then sat idle. The difference? World War I was slower, static. Fortifications mattered more. World War II was faster, mobile. Fortifications could be bypassed or reduced by air power. The Sixth Army surrendered at Stalingrad in February. The Battle of Kursk failed in July. The Allies invaded Italy in September. The Eastern Front collapsed through 1944. The Western Front opened in June 1944 with D-Day. Germany needed every resource for defense. Moving Gustav westward made no sense. It couldn't stop the Soviet advance. It couldn't stop the Allied advance. It could only be destroyed before capture, which is exactly what happened. He was too ill to stand trial. Multiple strokes. Car accident in December 1944. He died in January 1950. His son, Alfred Krupp von Bohlen and Halbach, stood trial instead. Sentenced to 12 years. Confiscation of assets. Released in 1951 after pressure from the U.S. government. The Krupp firm survived, rebuilt, changed. But the men who ordered and built Gustav were held accountable for their actions during the war. The Sherman tank was inferior to the Tiger tank in direct combat. One-on-one, the Tiger usually won. But America built 50,000 Shermans. Germany built 1,350 Tigers. The numbers mattered more than individual superiority. Gustav was the ultimate individual superiority weapon. One gun more powerful than any other gun, but only one gun. What if Germany had taken the resources spent on Gustav and Dora and Langer Gustav and built conventional artillery instead? The steel in Gustav could produce dozens of 105mm howitzers, hundreds of 88mm guns. The manpower operating Gustav could crew scores of artillery batteries. The railways built for Gustav could transport divisions instead of single guns. The strategic impact would have been greater. Not as impressive, not as memorable, but more effective. The record-breaking over the sufficient, the wonder weapon over the workhorse. The gun that destroyed forts, thought impregnable. The gun that vanished into Soviet scrapyards after one brief moment of service. The gun arrived late to its own obsolescence. 31.5 inches. He stares at the twisted metal. What the hell were they thinking? 2 years later, a young Soviet engineer examines blueprints seized from Krupp facilities. He studies Gustav's specifications, the barrel dimensions, the recoil system, the shell design. He makes notes. The Soviet Union is developing its own superweapons. They want to know what Germany achieved, what worked, what failed. The engineer reads the firing logs from Sevastopol, 47 rounds. He calculates the cost per round. He calculates the damage per round. He writes a report. His conclusion? Impressive engineering, poor strategic value, not recommended for development. The report goes to Moscow. Soviet military planners read it. They agree. The USSR builds conventional artillery. They build thousands of guns. They win the war. A demonstration that engineering excellence doesn't guarantee military effectiveness. The gun fired the heaviest shells ever fired. It destroyed fortresses thought indestructible. It represented the peak of heavy artillery design. And then it disappeared. Destroyed by its own creators. Forgotten by everyone except historians and military enthusiasts. The largest gun in history reduced to a footnote, a curiosity, a what if. But in June 1942, for 12 days at Sevastopol, Gustav was the most powerful weapon on Earth. 47 times it fired. 47 times the Earth shook. 47 times Soviet positions ceased to exist. For those 12 days, Gustav was exactly what it was designed to be. Unstoppable, overwhelming, absolute. And then it was over. The Bundeswehr Military History Museum in Dresden holds the world's largest collection of Dora and Gustav artifacts. Not the guns themselves. Those are gone. But photographs, documents, shell fragments. A piece of barrel with rifling still visible. Museum visitors examine these remnants. They read the specifications. They watch archival footage of the gun being assembled. They listen to survivor testimonies. And they ask the same question the American sergeant asked in April 1945. What were they thinking? From anywhere, at any time. They were thinking about prestige, about technological superiority, about wonder weapons that would intimidate enemies and inspire allies. They were thinking like engineers solving a technical problem, not like strategists managing limited resources. A brilliant solution to the wrong problem at the wrong time. And in war, timing is everything.